Oh, you won't believe the roasting that the examiners gave students and their teachers after marking this A-level maths question last summer. In the examiner's report, the examiners said this question was poorly answered, with the majority of candidates simply unable to engage with parts B and C. Some candidates did not appear to understand what was being asked of them. This betrayed both a lack of understanding of logarithms and also a lack of practice on similar past paper practice. The general understanding of the laws of logarithms was very poor. Examples of conceptual misunderstandings were numerous. Oh dear, don't let it happen to you this summer. How can we answer part A then? Well, we're given log to the base A of 256. So we need to find a link between 256 and either 16 or 25 through multiplication or through powers. I can't think of a link to 25, but I can think of a link to 16. If you try dividing in your calculator 256 by 16, you'll get 16. So 256 is 16 squared. What law of logs can I use to simplify this? Well, you should know that there's a law of logs that allows you to bring the power to the front here. So this is 2 lots of this log, and this log, remember, was p. So we can replace that with p. We get part A is 2p. What about part B? We've got log to the base A of 100. Can we find a link between 100 and either 16 or 25 through powers or multiplication? I can't think of a link to 16, but I can think of a link to 25. 100 is 4 times 25. What can I do with this now? Well, you should know a law of logs that allows you to split this log up using addition. We say it's log of 4 plus log of 25. What can we do with log of 25? Well, we can spot that that is q. So that can get replaced by q straight away. But what about log to the base A of 4? Well, you should know that 4 is the square root of 16. There's a link to p there, isn't there? The square root of 16 can be written as a power, 16 to the power of a half. What can I do with this now? Well, I can use the law of logs that allows me to bring this power to the front. So the half can come to the front, and then log to the base A of 16 is p. So that can get replaced with p, and there we have the answer to part B. What about part C? Well, we have log to the base A of 80 multiplied by log to the base A of 3.2. Let's start with 80. Can we find a link between 80 and either 16 or 25? I can't think of a link to 25 through multiplication or powers, but I can think of a link to 16. In fact, if you try dividing 80 by 16 in your calculator, you get 5. 80 is 16 times 5. What about 3.2? Can we find a link to that with 16 or 25? Well, if you type 3.2 into your calculator and get it to convert it to a fraction, you'll get 16 over 5. Or you might just know it's 32 over 10, which you can simplify to that fraction. How does this help us? Well, we've got that link to 16 here in both of these cases. But we need to use some laws of logs to simplify it further first. What law of logs can we use to simplify this part? Well, we can split it up using addition, like so. And what about this part here? What can we do with that? Well, we can split that up using a law of logs that says we can subtract log to the base A of 16 minus log to the base A of 5. How is this helpful? Well, this part we notice is p, so that can get replaced straight away with p. What about the other part, log to the base A of 5, that appears here and here? Can we find a link to either p or q? Well, 5 is the square root of 25. In other words, it's 25 to the power of a half. Again, we can apply that law of logs that allow us to bring the power to the front of each of these. So we get the half here and here. And now we notice that this part is q. So we can replace that with q, and we end up with this bracketed expression here. You could leave your answer like that, or you can expand the brackets to get this. Either way, you'll get full marks.